So this is ELC 131, Circuit Analysis 1, and the topic of this video is magnetism. Now, we think back to 4th grade, 5th grade, 3rd grade, and in my class, the teacher took a permanent magnet, a bar magnet, and laid on top of that a piece of typing paper. Back in those days, it was typing paper. And gently sprinkled some iron filings on top of that paper. And we saw that those iron filings would align themselves along with the magnetic lines of force, or the magnetic force that existed inside and around the outside of that permanent magnet. So the first quantity we need to define is flux, symbolized with the Greek letter phi. And a lot of us, and you'll hear me say this also, that refer to flux as magnetic lines of force, but understand these are not really lines of force. It's just we draw this force as lines because it's really the only way we have to graphically represent this force that exists inside and outside or around a magnetized material. Now, flux is measured in Webers. The unit symbol is capital WB. And the definition of a Weber is that if a magnetic force of 1 Weber changes in 1 second, it will induce 1 volt of potential difference in a conductor that is through that flux. So when we look at our representation of this magnetic force that exists in and around this permanent magnet, understand that this force is represented by lines, and these lines are closed loops. As you can see, they have no beginning and they have no end. And these lines of force also have direction. These lines of force leave the North Pole and enter the South Pole. These lines of force can never cross. And also, these lines of force, or the lines of force going in the same direction, are repelled from one another, and the lines of force going in opposite directions are attracted towards one another. So if we look at 2 permanent magnets placed such that their poles are north to south and north to south as shown, then what is going to happen is that these lines of force will link together and pull these magnets back towards one another. And we've all seen this happen, that if we take 2 magnets, north to south, and get them close to each other, those magnets stick together. And it's because their lines of force, the magnetic force existing around these magnets, link together and pull these together. Quite similar to what happens with charged bodies and electrostatic force. That if these bodies are oppositely charged and placed in proximity, then these lines of force will link together and pull these bodies together. Now, if we have these magnetic lines of force, or this magnetic force going in opposite direction, these permanent magnets will repel. And again, you've seen that before. If you have a magnet north to south and a magnet north to south and try to put the south poles together, they won't go together because their lines of force push each other away. And it's the same thing that happens with charged bodies and electrostatic force, that if we have two similarly charged bodies, then those two bodies are repelled because the direction of their force is opposite to one another. Now, quite often we're not that concerned with the amount of force we have in Webers. What we're concerned about is flux density. Flux density symbolized with the Greek letter beta, and the unit of measure is the Tesla. Then the unit symbol is the capital letter T. Flux density is really just the amount of flux we have in some area. So if we look at my sketch of a permanent magnet and the magnetic force around that permanent magnet, what we're concerned about is the amount of flux that exists in some area. 1 Tesla equals 1 Weber in 1 square meter. So again, magnetic flux, I will refer to it as, and a lot of people refer to it as, magnetic lines of force. But again, they're not lines of force. We just represent this force by drawing lines. And these lines of force are closed loops. They exist inside and surrounding the magnetized material. These lines of force cannot cross. They have no beginning. They have no end. And most importantly, these lines of force have direction. They exit the North Pole and enter the South Pole. And it's these lines of force that cause these magnetized bodies to be attracted or repelled.